Hey, Kevin here again. I was gone on a snow vacation for the past week, and when I got back today, I cracked out my MSP and my prototype binary watch that I've been working on for a while now, and tried to do some external programming following a bunch of work that I did on a new watch circuit to compensate for some problems I was having with this one. And what I found was the problems that I was having, were an artifact of the MSP chip being inside of the development board when I was running my tests. And so as soon as I took it out of circuit, or out of the development board and put it on an external circuit and then ran lines to program it externally, I found that I no longer had those problems. So here is just a simple demonstration on what I'm doing. So here I have a board, a PC board that I designed and then did toner transfer method to make the mask on a piece of copper clad, then etched it in chemistry, and then soldered LEDs on to. And so this is my watch board. It has space here at the bottom for this lithium polymer battery to drive it away from a wall power source, and for all the other driving components, including the MSP, the filter capacitor, and the resistor, which is behind those wires that you can't see, to tie the reset pin high so that the MSP stays on to run the program. So what I'm doing here is I'm Charlie plexing 20 LEDs to run this binary display from 5 pins on my MSP. And so the arrangement here of the LEDs is a standard watch face, like you'd have hours, minutes, and seconds, except it's broken up into the 1s and 10s places of each of those 3 parts, and then put into binary. So this first column here on the right is the 1s place of the seconds, then from right to left, 1s place of the seconds, 10s place of the seconds, 1s place of the minutes, 10s place of the minutes, 1s place of the hours, and 10s place of the hours. This is a 24-hour display, so when I started this program running, it started from 0 and counted up to where it is now. And the display goes from 0, which is 12 o'clock midnight, to 23 hours, 59 minutes, and 59 seconds, which is 1 second before midnight. And so this display is actually not true binary, since it does not display minutes, hours, and seconds in binary. Well, actually, that isn't even true binary. What would be true binary is displaying just seconds, and then you having to figure out what the appropriate time is from that, but that's a little bit too complex for most people to handle. So this was my easy display, which only requires you to know binary up to 10. Actually, not even, up to 9. So that's a little bit easier for those who are not yet binary competent. So my second version design, which was to fix the problems that I was having with this board, allows you to configure it to either show numerals, as in Arabic numerals, and letters on the display. This is an LED matrix display, but I wrote my own font to be displayed in 3x4 pixels, so it's able to be run on a display of this size. So you can either display numerals, you can display binary horizontally, seconds, minutes, hours, you can display only seconds, again horizontally, from right to left, top to bottom, so more like the actual Arabic writing system. And or you can display the simple binary like this, separated into columns for each of the parts of the time. So that second design I created because this first design had other LEDs that I didn't mean to light turning on because my inputs on my MSP were not high impedance enough to prevent other LEDs from turning on. The way that Charlie plexing works is you have 2 pins that you control at a time to control one LED on the board somewhere, and there are 5 lines here, and so there are 20 total combinations of high and low in either direction across these 5 pins that allows you to control 20 LEDs, because LEDs are diodes and so they only drive in one direction. However, this circuit design requires that the unused pins in the current cycle for controlling whichever LED you're controlling are set to input or high impedance, so that way all the other LEDs behave as if they are disconnected from the circuit entirely. Now, that was not the case when the MSP was inside the development board. I don't know why just yet. I haven't played around with that. But when I had my MSP in the development board and was running this LED display externally from the MSP development board launchpad, I discovered that other LEDs were turning on, and that was due to the fact that the inputs were not high impedance enough. So when I took it out of board to test out external programming for my latest watch design, which accounted for this problem, I discovered that it wasn't a problem at all. So that's a little bit annoying, but that's a product of my own ignorance, sadly. However, this board here took me a very long time to make, and I want to salvage it, especially because it has a whole bunch of LEDs soldered to it, which were pretty expensive, considering my low amount of pocket change to throw at projects like this. So I'm going to salvage this board from my own watch, and the board itself uses through-hole components for everything except for the LEDs. The LEDs are all SMD, but due to size restrictions, but the MSP chip here is the one that's actually going to be inside this board. So that is a through-hole component, and I have through-hole spaces on this board, but they're all on the top surface because I didn't want to make a double-sided board, because that's just a pain when you're doing the toner transfer method. And so I have to solder these components in pins down in this orientation and then solder them to the top surface, which is a pain, because usually you'd solder through-hole components on the bottom. But oh well. So the hole in the middle is for this battery, and the battery fits in right here and is connected to 2 terminals on the board. Now, this board does not have a 3.7 volt voltage regulator, which would allow higher voltage charging of the watch. And so this watch has to be charged using a hobby RC charger, like the one that was used to charge the helicopter that this battery came from. So because most people don't have helicopter chargers, I mean, that's a safe assumption, I redesigned my second board to include a 3.7 volt voltage regulator to allow charging from USB, which is 5 volts, or 5.5 volts, or 6 volts, or whatever voltage your computer drives your USB ports at, probably 5 volts. From the USB standard, I've experienced ports that charge at 6 volts, which is a nuisance for certain projects, but that's not important. So my second board accounts for both the high impedance problem, which actually isn't a problem at all, and for external charging with USB. So my second board also has points on it for programming the chip in circuit, which will be an SMD chip, as the second board is entirely SMD, which makes it easier to design the faceplate, the diffuse plate, because these watches will not be just bare like this, just a bare PCB. They will have a piece of white plastic on top as a diffuse plate for the LEDs. I'll give you just a quick demonstration with this piece of paper to indicate what I mean. So as you can see, the LEDs don't show up as specks, but rather as diffuse spots on the sheet, which looks a lot cooler in my opinion. So it makes it a lot easier to design the diffuse plate because the height of the components when they're SMD is a lot lower than the height of the components when they are through hole. So second board is all around a better design, but this board is nice the way it is and took me a long time to make, so I'm going to save it. So I have a DigiKey order put together with all the components for my second version board design, and I'll be sending that out sometime this weekend, and I'll get the components between next Saturday and probably Monday or Tuesday. So the boards I will be etching either at home or in chemistry class again for the second version watch, and then I will be milling the face plates at home and then assembling them all together on my own. And then hopefully when I'm all done I should have 5 high quality binary watches with full support for all of the display modes that I described previously, plus setting them in real time. And so there's a software component that goes into that. So yeah. Oh, and to demonstrate the in-circuit debugging, or programming, I'm just going to run the debug cycle on my computer here, which will erase the memory on the MSP external from the launchpad, reprogram it with the same code, and then start it over. So if I hit debug, you'll see what I mean. Damn. Code Composer is being difficult. It seems that I've been experiencing problems with more than just my hardware, as my software suite, CC Studio, which I use to program these devices, is missing a file somewhere that prevents it from restarting debug sessions properly. So I have to restart the whole program every single time I try to debug this thing, which is extremely frustrating. So I'm just going to debug it again. Hopefully it won't crash this time. And if you watch the LEDs, you'll see that they will turn off when the MSP is being flashed, right here. And then the debug cycle ends on my computer, and now I will press the run button, and there will be a short delay for initialization, and then the LEDs will turn on and begin counting up from 0. So there you can see it's now at 6, 7, 8, 9, 10, and as you can see it shifted over to the next column as it moved into the tens place. And then here it'll do it again, 8, 9, 10, and now it's at 20, so the next column shifted up to 2, which would be the second light. So yeah, that's pretty much it. Stay tuned.